Hello, I'm Bretton, one of our MCAT tutors here at Inspira Advantage, where we help students get into medical school and other professional programs. Welcome to MCAT Bites. Today we're exploring Le Châtelier's principle, a fundamental concept in chemistry that explains how systems at equilibrium respond to changes. This principle is crucial for understanding the chemical reactions in the body and beyond, netting you a ton of points on not only Chem Phys, but also the biochem sections of the MCAT. Now, if you're really lucky, cars. Le Châtelier's principle states that if a dynamic equilibrium is distributed by changing the conditions, the position of equilibrium will move to counteract that change. This is observed when we alter the concentration, temperature, or pressure. And remember that if we change pressure, volume is also probably changing. So what is a dynamic equilibrium anyway? Well, it means that both the forward and backward reactions are occurring simultaneously, but the average quantity of product and reactant aren't changing. For example, as one unit of product is formed, one unit of product is also converted back into reactant. This is represented by the symbols you'll often see shown here, 2 arrows on top. When we increase the concentration of reactants, the system will shift to produce more products, replacing the impact of the change. Conversely, increasing the product concentration will shift the equilibrium towards reactants. How about temperature? Well, increasing temperature in an endothermic reaction will shift the equilibrium to the right, producing more products. However, in an exothermic reaction, higher temperatures favor the reactants. Pressure is a really common one the MCAT likes to try and trip you up on. Changing pressure affects gas equilibria only. So if you have solids, completely ignore it. We only care about gases. If we increase gas pressure, we are always going to shift to the side with fewer moles of gas. Don't worry, we'll do some practice problems to better help explain this. Think about how changes in volume should affect a right or a left shift. Well, if volume increases, then pressure will have decreased. Therefore, the reaction shifts to the side with more gas. And how do I know this? Well, good old PV, PV equals nRT. And if we hold everything else constant, say our nRT isn't changing, but I decrease my volume, and pressure must increase to maintain our nRT. Now, I know it can be very difficult to understand what's going on when we just look at the definitions of Le Châtelier's principle. That's why I put together a bunch of practice problems to help us understand this. So let's start walking through them. Starting with problem 1. A system at equilibria contains hydrogen, iodine, and hydrogen iodide gas. If the concentration of hydrogen gas is increased, how does the system respond to reestablish equilibrium? Well, let's draw out our reaction first. So we've got hydrogen, iodine, and this is turning into hydrogen iodine. Now this isn't balanced, so let's add a 2 to balance our reaction. And basically what we're saying is we're increasing the amount of hydrogen gas. Since we're increasing the reactants, this is going to push our reaction towards the right. So we are going to increase our amount of hydrogen iodide gas. All right, now problem 2. In an exothermic reaction, shown here, N2 plus 3H2 is going to make 2NH, plus giving off some heat. What will happen when the temperature is increased? Well, we can think about this in the same way as before. We are increasing our heat, so this is going to cause a left shift. So we're going to favor the reactants. Now let's take a look at problem 3. For the reaction shown here, what effect does decreasing the volume of reaction container have? Well, let's write out PV first to make sure we don't make any silly mistakes. So we are decreasing the volume. It's going to mean we are increasing the pressure. And what do we know about increasing the pressure? Well, if we increase the pressure, the system will shift towards the side with fewer moles of gas. So we need to figure out how many moles of gas we've got. 2 SO4, 1 of O2, so this is 3 total, and just 2 of SO3. This means we're going to shift towards the 2 side. So this is a product-favored reaction. Now on to problem 4. A system at equilibria contains A and B, both are gases, in a 1-to-1 ratio. Okay, let's write that out. If some of A is removed, how does the system change? Okay, so essentially we're just going to decrease A. Well, if we decrease A, we're going to have to pull to the left to rebalance that. So we are going to lose some B, and we're going to increase. On to the last problem before you've mastered Le Châtelier's principle for the MCAT. In a reaction where X gas plus heat makes Y gas, what happens when the system is cooled down? Well, cooling down the system is going to basically just remove some heat. So I'm going to say that's a down arrow, causing the equilibrium to shift towards the production. Now, when we remove the heat, the reaction will shift to the left to compensate, causing fewer products Y and more reactants X. Le Chatelier's principle is tested all the time on the MCAT, whether directly or indirectly. Thank you so much for watching our video on Le Chatelier's principle, and I'll see you next time.